Hello and welcome to the uncertainty stage. My name is Sebastian Klöß. I'm head of consumer technology, AR, VR and the metaverse at Bitkom, and I have the pleasure to guide you through the first half of this afternoon. Today on this stage, we will be discussing with industry experts how businesses can navigate through and orientate themselves within the quantum computer ecosystem. A quick note on the procedure. The speakers will appear on the stage according to the program, and the very last version of this program can be found on the Bitkom event app. Please feel free to bookmark those sessions you do not want to miss there. After the presentations and after the sessions, we can take questions if we have time. Otherwise, please feel free to contact the speakers after the presentations, and I'm sure they will be happy to answer your questions. The start of this program today will be a panel discussion, Quantum Tech in Research and Industry Beyond the Hype. Quantum computing has long been an object of fundamental research. However, recent advancements in quantum technology have given rise to a quantum industry and thereby raising expectations for practical applications of this technology. The panel focuses on the interaction between, on the one hand, the scientific aspects, on the other hand, the business sides, and we will show how to bring these two sides together for quantum computing. The speakers today are first Regina Kirschner. She's product owner at Porsche Digital. Through many years of experience at Audi and Porsche Digital, she has learned both sides. On the one hand, the daily business of a car manufacturer, and on the other side, how to successfully implement new digital products and approaches within a company. And now she's part of the quantum team at Porsche Digital and tries to find use cases of this technology. Give her a very warm welcome. Next on the stage is Paul K. Fährmann. He's research assistant. He studied theoretical physics in Berlin and Copenhagen and is now a doctoral researcher at Freie Universität Berlin. And his work is around quantum algorithms, both for near-term devices as well as fault-tolerant quantum computers. And he tries to bring together these two worlds. And the third person on this panel is Dr. Peter Soldan. He's head of quantum systems project management at VDI Technologiezentrum. And he's responsible for the management of funding programs on behalf of the German Federal Ministry of Education and Research, the BMBF, at the VDI Technologiezentrum. As head of quantum systems project management, he's engaged in project management on photonics and quantum technologies for the BMBF. Peter holds a PhD in theoretical physics. Give him a warm welcome. Maybe let's start with you, Regina, first. What is the position of Porsche Digital regarding quantum technologies? I mean, where do you see the potentials and challenges of this technology for you as a company?
So, quantum technologies for us are super interesting technology. So we not only look at quantum computing, we look at communication and sensing as well. And within these fields, we try to figure out what are the must, cans and nots for Porsche or for the automotive industry, to figure out where we should really dive into and where is, maybe this is nothing for us. And within these fields that we identify as a must or a can, we look for research collaborations, as with FU Berlin, to dig deeper into it and shape the fields also regarding our needs as an automotive company.
And why have you decided to go into this business?
As I said, we see many potentials here. For example, maybe we can, in the future, optimize our production flows further with quantum computers, or use sensors in for better navigation systems. But on the other hand, there are a lot of challenges as well, because we still have to wait like 10, 15 years for a useful quantum computer. So what will we do in the meantime? And this is what we as a team try to figure out.
Great, thank you. Let's move to the scientific perspective on it. Paul, how does the quantum hype manifest itself from a scientific perspective right now?
So there's 3 points I want to bring forward. The first one is that as scientists, we publish and we submit our papers to scientific conferences, and you always see how many submissions there are at these conferences, and the number of submissions just grows exponentially. It's harder to get into the most prestigious conferences because there's so much happening on the field. Secondly, in my own research, I design algorithms, and I want to test algorithms and not just write down some pseudocode and leave it for the future generation to test these things. But now that we have better simulators and also quantum devices, we can, on small instances, test our algorithms and thereby directly compare them on small instances against other algorithms and see how their potentials might be. And thirdly, kind of a negative thing, when you read a lot of papers, also from companies, they're well written, there's a lot of good scientific input there, but then maybe a week later you read a news article and suddenly everything is just blown out of proportion, and they talk about quantum advantage today, a billion qubits in a few years, and practical applications now. And as a researcher, I'm just looking at the paper they're referencing and wondering how they come up with these things, and navigating this landscape, and also talking to industry and kind of clearing up what is a dream and what is not is a hard thing to do.
Yeah. So, nevertheless, the hype helps you as a researcher, or is it more a difficult thing for you as a researcher to correct the hype?
I think it's more inspiring for me because there's just so many more people to talk to and so many more discussions to be had and so many more ideas to develop. And I mean, if the size of the conference grows, there's more people to talk to, more people are interested in your work, and more people who give you new ideas in where you could push your work to. And I think that is really something that elevates the scientific output that you can generate.
And how big is the hype compared to the real technology we have right now from a scientific view?
Too high.
Too high, okay.
Way too high. But I also want to stress here that there's also scientific reason for hype. There's a lot of cool things happening, a lot of hardware advances, a lot of software advances, and even if you take away the hype of promising some advantage in the next year or so, there is so many interesting things to talk about. And yeah, I mean, the number of conferences where people do exactly that is just growing and growing, and I think that speaks for itself that there's a lot to be said and a lot of positive to the hype as well.
Absolutely. I think it's very important to see that it's a hype, but nevertheless, there's a scientific and a technological basis of this as well. Peter, how is your view on the scientific and the business side, because you are kind of in the middle of both?
Yeah, I'll try to be a mediator. So first, I want to stress that a hype is not a negative thing. A hype is a prerequisite to be successful, to build up an ecosystem in such a disruptive technology like quantum. So we need to bring the best minds in the field. We need to bring new talents in the field, technology makers, and of course the money, public money, funding, and private money. And this is part of the hype, and we need that hype. And then, of course, part of the hype is this valley of disappointment, and we have to go through this valley. And yes, we try to mitigate the hype, but we use it. We all use the hype, and it's an important thing to do that. And we have to know that we are part of that hype. But then the next thing, we are funding joint research projects. So we bring the companies in. So we bring the companies in to speak with the scientists, with the researchers, to get a view into the development, but also to get a realistic picture. We don't expect real use cases in the next 1, 2, 3 years, but we want the companies to deal with the technology. So from the user industry aspect, this is the important thing. I think the technology companies, well, the established companies, they know about the hype, they can mitigate it, they understand what is going on. The startups have to be part of the hype. It's their business, of course. But the user industry is the important point. There can be too much disappointment, and we have to deal with that. And so we bring the people together. We bring them in joint research projects to play with this technology, to look 1, 2, 3 years what could be a use case, what could be the translation from their the certain specific knowledge, their domain knowledge from the company to the quantum algorithm. So bring the people together. I think this networking is the most important thing to mitigate the hype. For public, I don't know. I think journalism is part of this hype, and it could be helpful anyway. And the last thing, we work for policymakers. I think this is even more important to mitigate this hype with the policymakers, not only with the companies, because everybody now is afraid of this quantum winter thing, so that there's no funding, because all the politicians are disappointed because they expect the quantum computer to work in 3 years or so. So it's our business to speak to them, to explain that we have a horizon of 10, 15, maybe 20 years. Nobody knows today. And that's the most important thing. So to bring all the people in this ecosystem and to get this understanding also into the heads of our policymakers.
How do you avoid complete sadness when you told politicians or companies that they have to wait for 15 or 20 years maybe?
That's difficult. We are part of that hype. I mean, the money which goes now in funding is much more than we expected a few years ago. And yes, there are very interesting things which happened in the last few years, so we can show there is something going on, but there won't be any use case from a universal quantum computer, at least in the next 5 to 10 years. We expect use cases from hybrid approaches, and of course we're looking at that. And we try, by the way, not to start with quantum computing, but with sensing and so we have the first few examples where we think in the next few years there will be product ideas, I would say. And we try to sell the success stories, but of course, on the other hand, we try to write down, for instance, internal papers to give them the truth. And it's difficult for a politician because a policy is made for 4 or 5 years, not for 20 years. They have to deal with it. We try to explain every day.
A hard job, I think. But nevertheless, Regina, you and Porsche Digital, you have decided to enter the quantum world, and you have decided to cooperate with universities, with researchers. How is this going, and what's the benefit of it, or why are you doing it?
So first of all, how our research collaboration looks like. So we have a joint funded BMBF project, and we have a shared PhD student, Alisa, my colleague. She cannot be here right now because she's at Caltech in California. And she is part-time here and part-time there. So part-time she is with me, with Porsche Digital, discussing automotive use cases for quantum technologies. And the other 50% she sits next to Paul and discusses some formulas at a whiteboard. Of course, sprinkled with a lot of home office in between, as we know, all of COVID. So she's bridging between the automotive side and the university side. And for this, we can discuss our ideas that, for example, I bring from the automotive perspective, or she brings something after discussion with Paul to me, and we see if we have an automotive use case for maybe a much simpler problem. And this is how we try to accomplish it, and it's very helpful for us because when you read something in the news, or a startup comes up with an idea and says, hey, you really need this for autonomous driving, we're like, maybe, and then we can go to our experts and our colleagues and our network and ask, like, is there really a thing, or is it just a hype? And then they tell us, yeah, maybe. And so we can have a lot of fruitful discussions here.
So, and what are your expectations if you say if you decide to cooperate with a university, etc.? Do you have a clear aim in your mind, or is it more work in progress you would like to do with the university?
Of course, it's both. It always has to have a relationship to automotive industry. We will not look at something that's maybe totally out of our sphere, but within that we are totally free, and we're also free if the discussions show that maybe this algorithm does not fit to our problem. Then we have also a result, this is not fitting to our problem. But like, we don't have like this use case we have to solve. We are free in discussing different use cases and discussing different algorithms and different Ansätze to cooperate here.
Paul, you're on the other side. What are your expectations or your hopes when you cooperate with a business like Porsche Digital?
To get an insight into what is needed. So if I write an algorithm, I can apply it to a bunch of problems. Usually in quantum physics, we have the Hamiltonian, which encodes the problem. And as a physicist, you're more or less creative into coming up with your own problem you'd like to solve, but that might be completely useless in practice. And then you turn to people like Regina and ask them, well, this is a kind of problem we can solve. Can you give me parameters that give a fruitful problem, for example? Or another example where you have some kind of algorithm and one part of the algorithm can be changed to other parts, and then maybe there is for example, in the chemical industry, where they deal a lot with quantum chemistry and simulation of molecules, maybe they have a molecule which fits better to your setup or is better suited to benchmark your problem than what you as a plain physicist who does not know much about quantum chemistry would come up with. And so these synergies help kind of find good benchmarking problems and compare algorithms and see where in which direction the focus should go.
So to put it in a nutshell, what is the benefit from your view to cooperate with a business? Of course, money, yeah, but is there more than money?
Real life insights.
Okay.
Like, as scientists, we lock our doors. We focus on a paper, on a computer, on the whiteboard, and we think about abstract mathematical problems, and to make like the problems not abstract but have good examples requires knowledge, and as a PhD student without much background industry, then you don't really have that insight. So talking to people who know more and who can kind of bridge this gap is very valuable.
And these discussions sound very simple and easy, but it really took us a while to find a language base, because like you are talking and thinking in formulas and I'm thinking in production flow and stuff like that. So it took us some time to find the same language, and also we turned use cases and algorithms back and forth until we found a little fit. For example, in one of our papers, you guys came up with a tic-tac-toe problem. It was like, nobody has this. And then we talked and talked and talked, and then I figured out, yeah, maybe we have something in autonomous driving, and then we published a tiny little toy case. This is more, could be in autonomous driving, and there we have out of once a real world problem, and maybe then it's easier also for other industries to adapt to this problem rather than to a tic-tac-toe example.
But what I want to stress here is that these are still toy problems, right?
Yes.
So it's like what you want to solve is like a huge problem, and you kind of shrink it down to something that a classical computer could do very easily, but just to put your quantum algorithm on it and see how it performs. And like, if you have a very simple problem which requires 4 qubits and your quantum algorithm does not even manage to outperform, or does not even manage to find something which is similar in performance to what a classical computer could, then, well, maybe you should adapt your model, or maybe you should do some more research.
Yeah. Is it special? Is this cooperation special regarding quantum computing, or are these problems and the challenges and the different views true for every research project or for every cooperation between business and universities?
I can only speak for this collaboration. I think here we have a good fit, especially with my colleague Alisa within, because she knows both sides. So she has been a working student for Porsche. Now she's an employee here, PhD student. But she also is a trained physicist, so she can speak both languages. And I think this is a really big plus that she's so versatile to switch back and forth here.
I think also what makes quantum special is that it's highly abstract and highly theoretical and highly academic, maybe more so than other research projects. So especially now that we have this hype and a lot of misleading headlines and misleading claims, navigating this landscape, I think, makes it more important that scientists and industry talk together, and also the lawmakers that, like, if you have to distribute the funding, you should better put it somewhere where it's used for a good cause, right? And not to, like, put forth too many expectations which are then not fulfilled and lead to a quantum winter. So.
But if you ask for the general aspect, I think that's right what Regina said. You always have this challenge to find a common language, because as I learned it, a scientist usually doesn't know about project plans. Of course, also in a scientific program, you have project plans, but it's a difference. There are no real deliverables, no real milestones. There's no system engineering in the end. So I think both sides have to learn. This common language is very important. I think that's the networking we try to do with funding, to bring these different minds together. So to bring them together behind a common idea, and that's not so easy.
Regina, you know this, the programs to foster these kind of cooperations right now in Germany. Are they good? Do you think they should be improved, or what's your the business view on them? Do they work, or what would you wish?
So I only can speak for our BMBF funded project that we have, and this is working really well, because our colleague is half funded with this project. She has the freedom to take her time to do the research. Of course, we have to run through some bureaucracy to do in the beginning. We have to make some reports, but it's once a year we present our results, and we even have the possibility to also show our results, our minor results or little results of some internal projects that we have, and they are very appreciated. So for us, this is working really, really well, but I only can speak for that. Yeah.
And Paul, what do you think? Are they working as they should, or should there be any improvements?
The ones I'm part of work as they should, I think, because then the Planck Network I'm part of has a lot of industrial partners which form use cases, and then they ping us, asking us for feedback, and so we can kind of do the hardcore research and also chip in with insights and give a reality check and sit in on discussions, discuss use cases, and at least for us, this seems to be working quite well, and the feedback we got from the industrial partners is also quite good. So, so far, yes.
Maybe I should say a negative thing.
Yeah.
We switch the roles. I think sometimes we are too complicated, because we start with 3 years projects, and that's often too much for user industry. They want to have the chance with a lower threshold to get into the game, to try with many projects about 6 months duration or so, and that's missing so far. And we discussed it internally how we could manage that with some test centers or so, where a company doesn't have to write a complicated project proposal, but just goes to the research institution and says, we have a project and can we do that together? And the money goes to the research institution, not to the company. We don't have that so far. So we have to lower the threshold for user industry. I think that's missing so far. Anyway, I'm happy about this positive comments.
Perfect. Let's move from the cooperation between industry, businesses, academia, to quantum tech, quantum computer use cases. You are all looking for or searching for the use cases right now. Where do you think are the first use cases, or where will be the first use cases we will have in daily use in industries and businesses? Regina, what's your opinion?
So of course I cannot foresee the future, and probably with quantum computing I cannot tell, to be honest. My personal opinion is that with quantum sensing there could be some future applications, because you can already buy them now. They are still very, very expensive, especially in regards to putting them in every car that we have. But we can try first tests and use them maybe for test benches and stuff like that. So I think this is a good, bridging technology, so to say, to overcome the quantum winter, because you can see first applications here. But for quantum computing, I cannot foresee the future.
What a pity. Paul, what do you think?
Similar. So, like, if I look at the math and I look at quantum algorithms, I want to find like a solid mathematical proof of a scalable quantum advantage. I look at problems which are so complicated and need so many resources that we're so far away from these that it's not sure what's going to happen in the meantime. And on the other hand, we have these heuristics, so like variational quantum eigensolvers, other variational algorithms, where people say, oh, but it's quantum, so maybe there is something, but there's no hard proof that gives me some kind of intuition whether to work or not. It will be heuristics. Maybe there's something, maybe there's not, but anyone who claims that their variational algorithm will solve real-world problems will ask them which archive paper, which journal publication they're referring to make these claims. And if I can't provide any, well, then you have your answer, I think.
Okay. Peter, what do you think?
Well, quantum sensing is the educated guess, yeah, sure. I think there are some products on the way, maybe in the fields where you don't look at costs so much, which is not automotive industry, but maybe medical industry. We heard this morning this example was with measurement of tiny currents for stimulating muscular signals. So that could be something. There are ideas for quantum MRT. Medical technology would be my guess for first application. For quantum computing, I tried to cite Feynman, who said if you have a quantum system, try to simulate that with a quantum system. So we are at quantum chemistry, and that's material. So material development, chemical industry would be my first guess. But of course, in the end, frankly speaking, nobody knows. There are so many optimization problems which could be useful already in this combination with hybrid approaches, with quantum computing and high performance computing that could be useful in the next few years. Maybe with a small advantage, just a factorial advantage. I think those things are doable in the next few years, and there are many possibilities here.
Okay. I think it's also you should make yourself aware that classical computers are pretty damn good, and we have very, very intricate models, classical models, which can solve problems which are just, even as a quantum computing scientist, like I wouldn't even dream of solving these on a quantum computer now. And on the other hand, like these specialized problems, like in quantum chemistry, you have chemists bashing their heads for years on these problems and really finding smart solutions, and now coming up with a quantum device which is still in its infancy, trying to outsmart these people. That will take a lot of time, a lot of work, and doing any prognosis there is, I think, quite unrealistic.
Yeah, of course we do not know which will be the first ones, but if you could wish, which should be the first applications or the first use cases, do you have a wish, Regina?
Maybe, as I said in the beginning, the production flow optimization, because our engineers are also bashing their heads all around, like for so many years, to make it more efficient, and they squeezed out every tiny bit. So if we could really have another benefit there, it would be really, really helpful. Or in simulating batteries, something like that. Yeah.
I don't have a very specialized wish, but more general one. Mario Badenburg spoke this morning about this ChatGPT moment for quantum. And of course, we all hope that we will have one, let's say, killer application, which is maybe too much, but a visible application, so that people notice there is something going on, to have another push for the technology and for the whole ecosystem, to have staying power for the next 5 or 10 years. So we would have really, I would like to have this visibility for staying power.
Do you think there is hope to have this in the near future?
Well, my hope is medical technology.
Okay, yeah.
Although I have to say the processes in medical technology take additional time to bring it to the market, to the people. And so it won't be maybe for the next 3 or 5 years, maybe more 10 years or so.
So the winter is going on, yeah?
Well, the winter is not there for a while.
Okay.
I think it's pretty good weather for quantum, no? Isn't it?
Good weather for quantum, that's perfect. Paul, what do you think?
I wish that it's something productive. So I think Shor's algorithm, even though it's a great example, is kind of a destructive algorithm. And even though like some of the subroutines can be used in problems with hidden subgroups, well, it's still a Shor's algorithm. It's still like this doomsday scenario of reading all your messages. And I'd prefer something more academically useful, like studying quantum systems in general, because if you have more insights into materials and quantum systems, then like suddenly like a new world opens up of possibilities we can't even dream of today. And going there instead of classical problems which are already quite studied and well solved by classical machines would be my hope.
Let's move on to another question. You all are in this business and you are have this cooperation, for example, you two. What would you advise individuals or organizations that want to engage with quantum technology and would not fall for the hype right now? Regina.
I would recommend to start with a small team. So we are only a few people and we're not investing like 50 people on that topic, but start small and build up an expertise. Expectation management towards your management. Always on my first slide I have like, we are not able to monetize it yet, but hopefully in the future. And this also means that don't waste your time of your colleagues, because they are, if I go to my colleagues, they are engineers, they have to design the new Porsche something, and they have a full schedule, and then I come with a topic that's 10 years ahead. They are like, yeah, okay, please come in 5 years again. So also be mindful what you want from them and how much time you need, and then find good collaborators, find researchers that you can talk to and know more about the field, and with that you can build your own opinion and be able to judge if this is just a hype or a real potential.
How do you manage to get money when you go to the C-level and say them it won't give us back money right now, but maybe in 5 or 10 or 20 years?
So we are quite lucky that the board at Porsche Digital really likes the quantum tech and wants to invest a lot of his resources in deep tech. But on the other hand, we try to, as I said, be a small team. Like we have so many employees at Porsche, we are 2-3 people, so it's not that much to invest. And we also try to, come up with value creation right now. So either we look into problems and then we see, okay, on the way to quantum, there's also a good classical solution to that. Maybe not as good as the quantum could be, but then it's quantum inspired, so you already have a benefit. And then we're trying to find KPIs that they understand. So if we're publishing papers, it's nice to have, but if we are, for example, filing patents or open source code, then it's even more interesting to them. They're like, okay, you're securing something, it's good. We're going to these conferences, we're going to quantum conferences, and we try to attract future talent, which is also we need these people in 10 years, or maybe already in 5 years to bring it into the car. So we try to show them the benefits, what we can already do, but keep the resources that we use low.
Okay. Peter, any advices for
Yeah,
companies?
I have a recommendation directing at universities and RTOs. Find a reward system for not only publishing nature papers, but doing technology development. I think it's underestimated in Germany. If you look at professorships or so, it's a high impact journal, which is the currency, and we should change that a little bit. Of course, it's very important, but it's a starting point. And then you have to go in technology development, you have to go even into systems engineering. And I would like to have the people in the quantum business already at the universities and at the RTOs who understand those steps. And I think we are not so strong in Germany at this point. We are very strong at the first steps, but when it goes to this collaboration with industry, it's not because people don't think about that, but there's no reward system for that. So we need the people, maybe with a permanent position, who also do engineering, for instance, and that's missing. So my recommendation would be, don't look only at the blue sky research, just go into the engineering.
Paul.
I think the best the best way forward for companies would be to send a few people to quantum conferences, like proper scientific conferences, talk to scientists, see how the community works and see what they think, because they're not, I mean, if they think something is bullshit, well then maybe they post it on Twitter, but if you're not part of the community, you won't see that. So if you go to the conferences, you talk to people, you ask them, what do you think about this application? I think you can gain much more, and like building these sustainable like research collaborations where you give the scientists some freedom and talk to them and get information back, I think that is something which is most promising from my side.
Great. We still have a couple of minutes. If you in the audience have any questions, please feel free to show me. Otherwise, I have lots more questions, but we have some questions in the audience. That's perfect.
Yes, one technology that you didn't mention before. You mentioned sensoring. You mentioned medical applications. How about in the quantum security area, quantum key distribution? Do you see that as a realistic thing, or is that? I know that there are applications. I mean, the Chinese have done things there. Is this blue sky, or is this closer?
I should try to give an answer from the funding side. It's closer. I think there's a certain maturity of the field. I see the needs for special markets, yes, for security, not for broader security aspects in communication, because the data rates are very slow, very bad so far. But there are special markets for that already today. Yeah, sure. Of course, I should have mentioned that, yes.
Also, there is good scientific roadmaps on like what needs to be achieved to like achieve a quantum internet, and then maybe you'll actually have a quantum device at home which does some kind of key distribution.
Quantum computer is still missing, so that limits the use cases. Yeah.
But I'd say like before you have a quantum computer at home, you'll have some kind of quantum communication device at home.
That's true. I think so.
There was another
If
question
at all.
over there.
Yeah, if at all, right. Although some phones already have quantum chips which are
Yeah,
like
sure.
supposed to be able to do some decryption things, and so it's already much closer to.
Interesting discussion. Thanks for your presentations and your vision for the future, but I respect applicability in technology. And Regina mentioned that there is a chance of have quantum computing in every vehicle. But from a user perspective, from a driver, why is that needed? Why do I need quantum computing in Porsche or in any other vehicle?
So probably, I mean, we will not have a full-fledged quantum computer that's run on 3 Kelvin. I mean, our AC in the Porsche is good, but not that good. But maybe at some point we have a tiny quantum node in it, and they communicate. We don't know yet. We have complex optimizations problems. I mean, our colleagues at Volkswagen are doing a lot to route optimization. So there a quantum computer could be beneficial, could be helpful, but we still don't know if we really need one in a car. And I think this is a very important, important to know that a quantum computer cannot solve everything. It's cool to have a quantum computer in the car, but maybe it's not necessary. And you always have to do the check whether it's necessary or not.
Maybe quantum sensing would be very nice to have in every car for absolute navigation, GPS-less.
For example, yeah.
I would be happy to see that.
I think there was another question first.
So you talked about applications in the quantum industry. What you didn't mention, of course, was in the financial industry. We're already seeing the first deployments of at least quantum-inspired algorithms, let's put it like that, for solving things such as the Black-Scholes equation for derivatives. And that seems to be probably even to be the first real application of quantum technology, simply because so much money is being poured in there just to get that little bit of advantage in the financial services.
Yeah, well, kind of depends on whether you call classic, like quantum-inspired algorithms, quantum industry. I wouldn't really. It's like more like a byproduct. But there was a recent Nature review paper where they go through different quantum finance like problems and solutions and checking whether there is proper mathematical evidence for an advantage. And mostly the answer was maybe, we don't know. So
So bad.
yeah, which is not so bad, but like I would expect something more rigorous to say that I expect actual things to happen there.
We still have time for one short question with a short answer.
Thank you so much for your talk, guys. I have a small question, like what is the analog for Tesla in Porsche company? Like, is this autonomous driverless vehicle, is it the aim of quantum sensing, or like using this quantum sensing technology for cars? Like, what is it about? Like making it autonomous, or like GPS satellites, these quantum nodes? Like, so like a team led in Tesla, they also I've heard they use supercomputer, I think, for this autonomous driverless vehicles. But is this something analogous, same?
So I haven't heard of a quantum team at Tesla yet, so I cannot speak for them. They are probably using supercomputers, but I don't know. For autonomous driving, there are different ideas right now, but nothing concrete. I just know, for example, about a patent that Mercedes filed about navigation without GPS in tunnels, because then you can use the sensor, and so for things like that, you could use a quantum sensor.
Thank you very much. Thanks again, Regina, Peter, and Paul, for your very inspiring insights in quantum technology and the use of it. Give them a very warm applause.